Okay, again, thank you so much, George and Tatiana and the other. It's very nice to, I would say, to be here. I'm at home actually, but to be with you and to see that so many people are here, and especially friends I know for a long time. So I would like, following Ratanzal talk, I would like to give a very brief view about urban soils, a subject on which I've been working for some years, I could say. So I'm in France, as you guessed, and you can guess also from my accent. And so Ratan already raised those problems: the world population increase, climate change, and so forth, the pandemics and the urbanization. And we are now almost all living in artificialized human environment. As you can see, those two lines, rural population and urban population, crossed in 2008, and definitely the humanity is becoming urban. And in this context, soils are essentials. They are very important component for life, but for human well-being, through the function they fulfill and the services they provide. So there are 7 main functions. I won't go into the details. You probably know those functions, but those are so important, and which means that soils are already raised by Ratan, are very important for life on this planet. And if we just have a look at the urban ecosystems, soils are everywhere. Of course, we live on soils. We use them for transportation, housing, and they also play a big role in the green infrastructures, parks and street trees, urban agriculture, the water cycle, climate regulation, global and also local climate, and biodiversity, and also, as already said, human health and the contaminants, and now the pathogen viruses and so forth. And now we know a little bit about urban soils, but it was not always the case, but because they were considered only recently. And if we take a look at old maps, like this one, this is an urban area. Those areas were not mapped. They were just depicted as white spot. Now it has become a bit different, and especially in the USA, there is still a big work going on, and Rich Shaw was one of the pioneers, and for his colleagues to develop mapping, urban soil mapping, which is very useful for city managers. And actually, in general, we imagine that human action generates uniformity. In some cases, it's right, but actually, if we look at the soil in natural environment, we know as pedologists that there is a big diversity in soil types, like, for example, in Europe, more than 300 soil types were observed. And if we go to agricultural areas, this is where uniformity is. And through soil tillage, uniformization, and artificial drainage, which reduce the surfaces which are waterlogged and under water influence. And in enterprise areas, actually, there is a high diversity, because human beings are doing so much changes in the materials, and you can see there are several materials here, and they introduce also organic matter and many other materials. So that's a very specific characteristic of urban soil, this high diversity. These are 3 examples of urban soil, very contrasted. An old garden, which this photo was shot in Moscow, in the Tolstoy garden. So you can see 70 centimeters of a very dark horizon, very rich in organic matter, very fertile, and with a high carbon storage. The second one is a soil, which is called a technosoil, because it's made of artifacts, material which were derived from human activities, in this case industrial activities, and it's almost only industrial material with some natural soil material. And there is some trees, you see, life is there anyway, despite its a technosoil. And the third one is soil under the pavement. We just see the pavement when we walk on the street, but under there are, you know, horizons and of course pipes. Why? We can see that when they open the street to work. And so 3 different urban soil with different, they fulfill different functions, and some are more important in the provision of services than the others. And those soils, we try to group them in 4 groups to make things a bit simpler. Actually, as you mentioned on the previous slide, we call them also SUITMAs, the soils of urban, industrial, traffic, mining, and military areas. Everywhere humans have a big impact. And this slide shows the sort of gradient of anthropization from urban forest soil to a silt soil with first group where the forest soil is pseudo-natural soil, then constructed soils, soil which are designed to fulfill the functions, soils of dumping sites, and the silt soils. And from the left to the right, the potential to provide ecosystem services is, of course, decreasing. I will just give you some 2 illustrations about soil functions and the services. And one phenomenon which is very common in urban areas, especially in parks, is compaction. And you see the impact on walking on plants. And this compaction introduces a decrease in the porosity. You can see from rural areas here to urban areas, to the porosity, mesoporosity and macroporosity all decrease. And the consequences are double. One, of course, it impacts the root growth. This is from agricultural soil, but the phenomenon is the same in parks. And also the infiltration is really poor. And this is not taken into account by people who, you know, make soils, people from civil engineering, which in general don't take care of the soil as a system, as a living system, and as a porous system. Another example is this gradient of anthropization. You probably recognize those places. This is Central Park, and so near Central Park, and we can say that there is a gradient of anthropization from Central Park, where if you don't see the buildings, you imagine, and you just shut your ears and you imagine you are in a forest. Actually, it's managed the way natural forests are managed. Leaves and branches are not removed, and so life is developing. And nearby, you have those trees, which are the street trees, which don't have the same life. They actually, trees are not equal in urban areas. And the territory, this is the example of the European Union, is more and more sealed. And the sealing has consequences you see on trees, without going into details, but the trees are really strong, and they are able to develop roots to get, of course, water and also to get nutrients. But it's still a mystery where do the tree get the water actually. So let's have a look about the connection between function services and the beginning of the story, which is the stocks. And the stocks are, let's say, inherited from natural capital, like clay, organic matter. So they are the stocks. And the stocks interact through processes like this one, aggregation, generating soil structure. And the soil structure is at the basis of a function, porosity and water infiltration. And then we can move to the service, which is the flood control, and which provide a safe environment, that the benefits we can get from stocks, processes, and functions. And this safe environment can be transformed, the benefits can be transformed into economical value. And at the end, we just go back to the stocks, and we are able to give a monetary value to the stocks and to the processes, which is what Ratan mentioned, and it's really important to give economical value to services. And in the case we have soil sealing, of course, the benefits are very low, and you have this this problem, you know, the flooding and the catastrophe. And the economical value can be obtained from the insurance payment due to the flooding. That's all. Okay, and if we have a look at biodiversity, how it is affected by anthropization. So this is a work which was done by my colleagues, and they analyzed the soil from forest, grassland, cultivated, orchard, and urban areas. And you can see those parameters like pH, organic matter, and lead content, they vary. Increase in pH when you go to the city, and the increase in lead as well, and the organic matter. So there are some changes from forest to agricultural land. There is a decrease in organic matter, and then an increase in urban areas, which are also a sink for carbon. And if we have a look at soil macrofauna as an example of biodiversity, so the number of species is really decreasing from forest to arable land and vineyard, and then we can observe an increase in the number of species in urban areas. Oops. There is a ringing. Means I'm too long. Okay, and if we look at the columbola, the species columbola, that's the same trend, a decrease from forest to the intensively cultivated areas, and an increase in urban areas, which is quite interesting. And finally, I try to make it brief, how can we manage soils to improve ecosystem services? In other words, how we can go from unused site to a valuable resource, like industrial site, which became a brownfield. So we use nature-based solutions like soil construction, and this helps to build agroforestry ecosystems. And for doing this, we can control soil pollution, reclaim soil function, and produce biomass. And then we can say that we contribute to circular economy by the recycling of land and waste, because we use waste to, for soil construction, and the other benefit is the improvement of ecosystem services, that provisioning of biomass for energy, fiber, food, even recovery of metals, and regulating services, biodiversity, carbon storage, and water cycle. And just an example, what we have developed on the brownfield, which were quite low fertile, doing this, taking this strategy, we built soil, we construct soil using compost, treated soil, paper mist sludge, that's an example. This is the constructed soil, and from this we can grow plants and produce the energy, fiber, metals I just mentioned. And the biodiversity, of course, increases, and which there are many benefits in the ecosystem service. So as a conclusion, I tried to show you that anthropization generates a large diversity of soils with special characteristics. I won't go again into the details. And those urban soils, they fulfill a large number of functions. They are major providers of ecosystem services, and they are manageable. We can build soils and we can get the services we want if we build the good soils. So there are two needs, to my viewpoint. First, better consideration by people running the cities of the soil as a volume and as a living organo-mineral system, instead of just a 2D system on which we put houses or walk or drive. And the second need is to design and build soils which would meet the demand in ecosystem services. Okay, so thank you so much for your attention, and many thanks to the ones who contribute to